Well, in 2014, we had two major projects that we've been running. We did some laboratory-based evaluations for abamectin, which is Agromec, and Spirotetramat, which is Movento. And we did an assessment of a lot of various rotational strategies to find out what we might use if some of these do begin to develop significant resistance like imidacloprid did in Texas. These are among the two commonly used materials in psyllid control. According to Gunther's paper, they're used on about up to 67% of the fields in Texas. And abamectin is also used in Kansas and Nebraska on many of the fields. Spirotetramat, or Movento, is used on up to 100% of the fields in Texas and Nebraska. The use levels are a little bit less in California, but they're still used fairly frequently. So we realized that there are no resistance management tests that have been done with psyllids from the Pacific Northwest, so we wanted to run that. And because of that, there's really no good baselines available for these compounds. We have good baselines for the neonicotinoids, which a lot of us are worried about possibly being lost, either through resistance, like imidacloprid, or through public pressure, because anything that produces a flower these days is going to be considered under threat by the beekeepers and the folks that are trying to save the bees. Our laboratory studies were pretty straightforward. I don't want to spend a lot of time on this, but basically we had the Spirotetramat or the Movento that was treated either on contact, which we did in 2006 when we first tried this study, and then after that we began to go to residuals because it's very clear that these work better once they're absorbed into the plant and they have a chance to move systemically through the plant. So we moved over to that strategy. The abamectin was applied 24 hours after the insects were put on the plant. Both were hand sprayed until runoff, and we followed all of these insects all the way through their life cycle until they died. We had 3 different psyllid colonies. One we call the Tex-06. That was given to us by Joe Muñiza, and it was originally collected in Weslaco, Texas, back in 06, and or even earlier, maybe in 2004, and we've maintained it in California without pesticide use for a number of years. One of the key results that I presented last year was once you have resistance to something like imidacloprid, it's very slow to decline, and that's one of the things that we've used this old colony for. The Texas 1214 was material that was collected by Don Henney originally in 2012. He sent us some new material in 2014, and that's one of them that we really wanted to focus on for the Agromec and the Movento. And then we have the Pacific Northwest colony provided by Joe, and that was collected this year. We wanted to test these because there's simply no data that we could find on how effective these were in the Pacific Northwest. Well, here's the Texas 06 from 2008, and this is why we don't use Movento as a contact. What you can see is that if you spray it when you put the insects on the plant, it takes a long time for them to die. There were 20 insects put on each plant, so 10 here is 50% mortality, which is not very good. So we tried it again with that same colony in 2008, and this time we treated the plants and waited 7 days. Before we put the insects on. Okay, we're going to try this again. There we go. And as you can see, we got nearly 100% mortality. So that's really the way to go with these. You don't expect immediate control. Put it on the plant and let it be absorbed into the plant, and then you're going to get much better control. Well, this is the results from the Spirotetramat just recently completed. We have the 3 colonies. The black one is the Texas 2006, the white one is the Texas 2014, and the gray one is the Pacific Northwest. And basically these down here, these are the proportion of the maximum field rate. So this is half field rate, and that's full field rate. We don't recommend that you use less than full field rate for abamectin. And in fact, if you're going to use that material, if at all possible, if the temperatures are cool enough and you have some experience and you can add a little bit of oil, we found that it doubles or triples the effectiveness. But the end result of this is that if you look at the Pacific Northwest, it kills 100% of the insects. There is no resistance that we can find in the Pacific Northwest to this. In fact, I'm sorry, this is Spirotetramat. And if you look at the older Texas one, you can see that we're getting pretty good control. The problem is that the new Texas colony, this white bar, we're only getting 85 to 90% control. This is a real concern to us because if you begin selecting a large colony of insects with 90% suppression or 85% suppression, there are a lot that survive, they can find each other, they mate, and they're much more resistant. So the potential there is for Spirotetramat to be lost in Texas before too long. It's certainly something you should be watching for. We did this with abamectin, and the good news in this is that abamectin controlled them in every case at the full rate, and in virtually every case anyway. It controlled the psyllids from every location. I didn't include California in this, but it's the same effect in California. Abamectin works great. So Spirotetramat works fine in California, works fine in the Pacific Northwest. There may be a problem developing in Texas. Abamectin works great in all locations. We then ran a series of field trials. Our goal is to find out what we might use if these begin to develop resistance. We had a whole series of different trials. We've worked with abamectin, Movento, and a bunch of the neonicotinoids. As I reported last year, imidacloprid is no longer functional in Texas, but we were still getting some pretty good control with thiamethoxam or platinum. We need to be able to manage resistance. We can't just continue to spray the same thing over and over again and expect to get the same level of control. These develop resistance fairly quickly. We tested a lot of different multiple types of rotations using these new materials. Everything was done in the field in large plot trials that could be sprayed with commercial application equipment. This was not done with a pivot, but we did use a commercial tractor application system. And we had 4 replications in a randomized complete block design. These are full-scale trials that were run in many cases for multiple years. I put this one in so you couldn't read it. I had a professor one time who showed a slide like this, except that it was black writing on black, and he said, if you could see this, you would see that. Basically, all I want you to see out of this is that we had a control with no neonicotinoids. What happens if we lose those? What's the best approach that we can take? We had a bunch of chemical trials, and all of these will be in the proceedings so you can see specifically what they are. But we tried to give them some names that you could use. This one, for example, has Torac built in it, and this one has Verimark, which is Cyazapyr from DuPont. And this one has Closer, which is sulfoxaflor, which looks very promising as well. So we had a bunch of these. We compared them to the most common IPM. This is the rotation that was proposed in Gunther's paper and has been used in a number of them. And then we had one other that we stuck in. This is methomyl and permethrin. It's been my experience in California. It doesn't matter if you work on potatoes, tomatoes, or peppers, that the first response of a grower is to go to Lanate and Pounce because they're cheap, they've worked on all the other insects, let's put those on and see if they work. And I want to show you what happens when you do that. Here's our first field count. Here are the different treatments. This is a control, no treatment at all except for water. There's no neonicotinoids all the way through to the IPM, and here's the methomyl and permethrin over here. It really blew them up, and this turns out to be a fairly common trait that we see. That was the mean number of psyllids per plant, and it's actually per branch on a plant. So we had some pretty good populations going, particularly in the methomyl and permethrin. We were up to about 15 insects per branch. And if you think about that, and you've got 8 or 10 branches per plot, that's a whole lot of psyllids. So the pressure was pretty high. We then went through and harvested all of these, took the normal types of counts, fried them up, and this turns out this lady is very popular when she has control fruit that are not infected. A lot of people from a lot of labs come over because they really like our potato chips. And we looked at the zebra chip results, and basically there's no significant difference. Although, interestingly enough, this methylpermethrin and the current most used program had higher levels numerically than anything else. There's always a danger of talking about trends in non-significant data, but they certainly didn't have lower bars than all of these others. So it's a pretty substantial problem that we were seeing, at least in our situation, because these were mostly above 20%. The one that worked really well was the Torac and the sulfoxaflor. At least numerically, they had a little bit less. Finally, I want to mention those broad-spectrum pesticides. And what I showed you is that this year we had a lot more on potatoes with eggs and nymphs. But this is the same thing with bell peppers in a couple of years. These are controls at the beginning, followed by different chemical programs that we've developed over the years. But this is the methylpermethrin standard that's so popular with the pepper growers. And what you can see is that it really blew the pepper numbers up. We had nymphs that were greater than 50 per plant in some cases. And in fact, this past year in the Sacramento Valley in California, they had a huge influx of psyllids. And they ended up with hundreds of psyllids on every plant. And at harvest, they went through and they had to issue toothbrushes to all of the pickers so they could use the toothbrush to get all of the psyllids off of the plants before they put them in the box. That's a huge cost, and they're really quite concerned about it. I think if those populations continue, we're going to see problems develop on maybe even processing tomatoes. Certainly the tomatoes in that area are going to be at risk. And if these are carrying any Labirobacter at all and they move into potatoes, we may see a response there as well. But certainly in peppers, the numbers are incredible. And the problem is you put on a compound like lanate or pounce, any number of synthetic pyrethroids, and we've even seen this in a case with other really hard compounds. If you spray them a lot, you end up with just tremendous populations of these. So you do need to be aware of what will happen if you do that. So, abamectin works every place. Pacific Northwest, California, Texas, it's still functional. There's no evidence of resistance in California or in the Pacific Northwest to Movento. We're worried about what's happening in Texas, and I think somebody needs to pay particularly close attention to it so that we don't lose this compound. It's important in our overall strategy. And within the context of insecticide rotations, we do have some new compounds that look promising. Torac does pretty well. Cyazapyr does extremely well as well. And sulfoxaflor, which is known as closer, also does pretty well. I think it's going to have a changed name for potatoes, but right now the common name that they use for this is closer. So these all work as potential rotational compounds that we could use. One of the advantages I think that we have is that most of these are as expensive as many of the other compounds that they're already using. And if they are expensive, then they use them less in Mexico. And if they use them less in Mexico, there's a chance that we'll be able to get some real mileage out of these before they start applying 15, 20, 30 applications of these materials over the top down there, and we have the insects migrating in. I'd like to thank some folks in my lab and some funding agencies, particularly Bill Carson, Greg Kuhn, Beatrice Vignola, and Chris Gilbert, who was our fry lady.